In the last two lessons, we used the first derivative test and the second derivative test to obtain information about a function, the intervals where the function is increasing or decreasing, the intervals where the function is concave up or concave down, where does the function has a relative maximum or a relative minimum, and we use this information to sketch the graph of a function. Now, certain functions require more information than what we obtained so far in order that we can sketch the graph of their functions. Now, one such information is what we call asymptotes. What is an asymptote? An asymptote can be a vertical asymptote or a horizontal asymptote. Now, let's take an example here. Let's say f of x equal to x over x minus 2. Now, what is the domain of this function? The domain of this function does not contain x equal to 2. Why? Because at x equal to 2 there is a discontinuity. At x equal to 2 the function value is not defined. So if you graph this function, you will not get an output at x equal to 2. So we say there is a discontinuity. And therefore, it is of interest for us to find out what happens to this function value as this x gets closer and closer to 2. X gets very close to 2, what happens? For example, let's say x equal to 1.9999. X is not 2 yet, but it is getting very close to 2. Now, this is the way we normally write it. Is that right? We talked about limit in our first class. Limit x approaches 2, let's write it the proper way. Limit x approaches 2 from the left, because 1.999 is a value left of x equal to 2. As x approaches 2 from the left, what happens to f of x? Alright, take your calculator out and replace x by this value, 1.99999, and tell me what the function value is. Well, this is the function value. It is negative 199,999. Is that right? Well, what we found is when you replace your x by 1.99999, the function value is 199,999. Well, so as x gets closer and closer to 2 from the left, where is the function value going? It's actually going to, well, this is negative, isn't it? Didn't the calculator give you a negative value? I think so. Yes, because the denominator is 1.9999 minus 2. That's negative. So this will be a negative value. What happens is the function is actually going towards negative infinity. If you now replace it with 1.9999999, you will get a much bigger negative quantity. So as x gets closer and closer to 2 from the left, the function value goes to negative infinity. Well, how about replace x by, try this now, replace x by 2.00001. Now what happens here is x is getting closer and closer to 2 from the right. Tell me what that value is when x equal to 2.00001. You get a value for that. Well, f of 2.00001 is actually 200,001. So when x gets closer and closer to 2 from the right, f of x goes to positive infinity. Now, this is the definition of a vertical asymptote. Now, listen to this carefully and learn what a vertical asymptote is. As x gets closer and closer to a particular value, here in this case it is 2, x gets closer and closer to 2 from the right, the function value goes to positive infinity. And as x gets closer and closer to 2 from the left, the function value approaches negative infinity. In such a case, x equal to 2 is called a vertical asymptote. Now, what is the graph of x equal to 2? X equal to 2 is a vertical line. And therefore, let's make it a general statement. Say x equal to c will be a vertical asymptote under what condition? For a function f of x equal to c will be a vertical asymptote if limit x approaches c from the left will be either positive or negative infinity. Well, I'm going to say positive or negative infinity. Similarly, limit x approaches c from the right is also either positive or negative infinity. If these things occur, then x equal to c is a vertical asymptote. Now look at our function. F of x equal to x over x minus 2. It's very simple to find the vertical asymptote. In order to find the vertical asymptote, what all you need to do is set the denominator to 0 and solve for x. So x minus 2 equal to 0. Therefore, x equal to 2 is a vertical asymptote. Now, when you draw the graph, how is it going to look like? Well, you know that as x gets closer and closer to 2 from the left, the function value goes to negative infinity. And as x gets closer and closer to 2 from the right, the function value goes to positive infinity. So it must be easy to sketch the graph of this function. Let's sketch the graph and see how. Well, that's your x and y axis. That is x equal to 2. And we normally draw the asymptote by broken lines. So what happens is, as x gets closer and closer to 2, the function value goes to negative infinity. And as x gets closer and closer to 2 from the right, the function value goes to positive infinity. And some time ago I mentioned in the class that if on one side of the asymptote the graph goes to negative infinity, then on the other side it will appear from positive infinity. That is a clue that we can actually use to sketch these graphs. Alright, that was simple. Finding the vertical asymptote is simple. Set the denominator equal to 0 and solve for x. Now, how about the horizontal asymptotes? Now, we look at the same function, f of x equal to x over x minus 2. Now remember, in the case of the vertical asymptote, we looked at the behavior of the function when x approached a specific value, in this case 2, when x approached 2 from the left or from the right. And how did the function behave? Now, in the case of horizontal asymptote, we are going to look at the behavior of the function when x is very large, either positive infinity or negative infinity. In other words, we are going to look at the limiting behavior of the function when x approaches infinity. Well, you can either go to positive infinity or negative infinity. So in the limit when x approaches infinity, what is the value of the function? Now, what do you think will be the value of this function as x gets very, very, very large? All right, let's start by this. Let's put x equal to 10. Tell me, what is the value of this function when x equal to 10? Now, I have found values of the function for x equal to 10, x equal to 100, x equal to 1000, x equal to 10,000. And what you notice, f of 10 is 1.25, f of 100 is 1.02, f of 1000 is 1.002, f of 10,000 is 1.003. So what do you think f of a trillion is? X equal to a trillion. And it is not worth going over there. It will be approximately 1. So what happens here is, in the limit when x goes to infinity, either positive or negative, well, the function value approaches 1. The function value approaches a definite number when the input goes either positive or negative infinity. That is the definition of a horizontal asymptote. So in this case, in the limit when x goes to infinity, f of x equal to 1. And therefore, y equal to 1. Look at the difference here. A horizontal asymptote is a vertical line, and a vertical line has the equation x equal to c, x equal to 1, x equal to 2, and so on. But a horizontal asymptote is y equal to. So in this case, y equal to 1 is a horizontal asymptote. All right, let's look at that one more time. Is there any way to find the horizontal asymptote without going through the exercise we just did? There is. Well, there are a couple of ways that we need to look at. If the degree of the numerator equal to the degree of the denominator, then it is very simple. Now, first of all, I want to discuss this. What is the value of, the limiting value of, say, x goes to infinity 1 over x? What is limit x approaches infinity 1 over x? Now, in this case, as x increases without bounds, the denominator increases without bounds, and the value here will approach 0. Is that right? 1 over a trillion is very close to 0. So, limit x approaches infinity, 1 over x is 0, or 1 over x squared, or any power of x. You have the denominator, that limiting value will be 0. That is something that we're going to use here. So, in order to find the horizontal asymptote of a function like this, we divide each term by x. Let's see what happens. Divide the numerator by x, divide each term of the denominator by x. And that gives you this, x over x minus 2 over x. It doesn't change the value. We divided the numerator and the denominator by x. What does that give you? Numerator is now 1. The denominator is 1 minus 2 over x. Therefore, look at the statement I'm going to make. We are interested in finding the limiting value of this function when x approaches infinity. So, limit x approaches infinity of x over x minus 2 is now the same as limit x approaches infinity of this quantity, because this is the same as this is the same as this. Will be 1 over 1 minus 2 over x. Alright, now tell me, looking at each term, what is limit x approaches infinity of 2 over x? Well, limit x approaches infinity of 2 over x is 0. So that will be 1 over 1 minus 0, and that is equal to 1. That's a very simple way to find the horizontal asymptote. And very often we don't even have to do this. What all we need to do is, if the degree of the numerator equal to the degree of the denominator, then the horizontal asymptote is the degree of the numerator, well, the coefficient of x divided by the coefficient of x in the denominator. Now we will talk about that in the next slide. Now, we know the vertical asymptote, which is x equal to 2, x equal to 2, not x equal to 1, as I have written here. That's x equal to 1. So x equal to 2 is the vertical asymptote, and the horizontal asymptote is y equal to 1. And we draw them by using broken lines. Now, what does these actually mean? We talked about it. We said the vertical asymptote means as the input gets closer and closer to x equal to 2, either from the left or from the right, the function value either goes to negative infinity or positive infinity. And horizontal asymptote y equal to 1 means as x gets very large, either positive or infinity, the function will get closer and closer to y equal to 1. So can you draw the graph of this? Well, sketch it. Well, let's do this. For very large values of x, the function value is very close to 1. So it's very close to 1, but as it gets closer and closer to x equal to 2 on the left, the function will go to negative infinity. Then, on the other side, as x is very, very large, the function value is very close to 1. And as you come closer and closer to x equal to 2, the function value goes to positive infinity. And you can see this information will help you to sketch the graph almost very accurately. We will now discuss some rules for finding the horizontal asymptote. Let's look at this function. F of x equal to 2x divided by 5x minus 3. We can use the same operation. Divide each term on the numerator and denominator by x. And so we can say limit x approaches infinity, and that's where you find the horizontal asymptote. Let x goes to infinity and see what happens to the function. 2x over 5x minus 3 is the same as we divide each term by x. It will be 2x over x over 5x over x minus 3 over x. And what does that give you? That will be 2 over 5 minus 3 over x. Now, what is the limit of this quantity when x goes to infinity? When x goes to infinity, 3 over x is 0. So that will be reduced to 0. Therefore, the limiting value of this will be actually 2 over 5. Or the horizontal asymptote will be y equal to 2 over 5. Can you look at this and give me a standard rule you can use to find the horizontal asymptote. The rule is, if the degree of the numerator equal to the degree of the denominator, they are both 1, is that right? Then the horizontal asymptote will be the coefficient of x on the numerator divided by the coefficient of x in the denominator. We call them leading coefficients. So the rule says, if the degree of the numerator equal to the degree of the denominator, then the horizontal asymptote is the ratio of the leading coefficients. These are the two leading coefficients. So the horizontal asymptote is the ratio of the leading coefficients. Look at this function. F of x equal to ax squared plus 2x plus 2 divided by bx squared plus cx plus d. If you look at this, the leading coefficient, what's the meaning of leading coefficient? Leading coefficient is the coefficient of the highest term. Now the highest term is x squared, and the coefficient of that is the leading coefficient. So when x goes to infinity, this function will approach the ratio of the leading coefficient. So that will be y equal to a over b. That is the first rule. So you can make a note of that. Rule number 1, when the degree of the numerator equal to the degree of the denominator, the horizontal asymptote will be the ratio of the leading coefficients. We now know one rule to find the horizontal asymptote. That is when the degree of the numerator equal to the degree of the denominator. What happens in a case like this, where the degree of the denominator is greater than the degree of the numerator? Well, what is the value of this? What is the limiting value of this? Limit x approaches infinity. What is the value of 2x over x squared plus 1? You see, because the degree of the denominator is higher than the degree of the numerator, as x goes to infinity, the denominator will increase without bounds, and ultimately the value, the limiting value of that will be 0, because the numerator will not be able to keep up with the denominator. The denominator will grow without bounds. As a result, for very large values of x, this will be 0. That means if the degree of the denominator is higher than the degree of the numerator, then the limiting value will always be 0, and therefore the horizontal asymptote will be y equal to 0. That's a very simple rule. So we got two rules now. Before we look at another rule, can you tell me, how does the graph of this look? Does it have a vertical asymptote? Remember, vertical asymptote is obtained by setting the denominator to 0. Now, can the denominator x squared plus 1 be equal to 0? No, why not? Because if x squared plus 1 equal to 0, it means x squared equal to -1. That cannot happen. So this will not happen. That means that denominator can never be 0. There are no vertical asymptotes. And the horizontal asymptote is, what is the horizontal asymptote? The denominator has a greater degree than the numerator, therefore the horizontal asymptote is y equal to 0. And therefore, how does the graph, well, approximately, we're going to sketch it. How does this graph actually look like? Well, for very large values of x negative infinity, the graph will be very close to 0, and as x gets very small, maybe the function is like that, and if you look at this, when x equal to 0, what is the value of f of 0? F of 0 is 0. So it will come and cross, and for large values of x, the graph will approach 0. That's a beautiful graph. Try and see that will happen in your calculator. Tell me, what do you think the graph of this function will look like? You see, always you must be inquisitive. When you see a function, immediately you must try and figure out how the graph is going to look like to get a visual picture. First of all, look at the denominator. Can this denominator be 0? No. And therefore there is no vertical asymptote. What is the horizontal asymptote? The degree of the numerator equal to the degree of the denominator. Therefore the horizontal asymptote is y equal to 2/3, the ratio of the leading coefficient. So if I want to sketch the graph, let's see whether we can actually sketch the graph of that. Now, if this is y equal to 1, y equal to 2/3 will be about that. That is the horizontal asymptote. There are no vertical asymptotes. Now tell me, when x equal to 0, what is the value of the function? X equal to 0, if you put x equal to 0, the function value will be 0. That means the graph has to touch the origin. Now, once you know that, it's easy to sketch the graph now, because as x goes to negative infinity or positive infinity, the function value is going to approach y equal to 2/3. So this will be the behavior to the left of x equal to 0, and this will be the behavior to the right of 0. As x goes to negative infinity or positive infinity, the value of the function will get closer and closer to y equal to 2/3. And see how a beautiful graph you can sketch without really having any other information. You don't even need a calculator. You want to try and test it on your calculator? We will now look at what are called slant asymptote. Well, we looked at vertical asymptote. Now, I want you to have a clear idea on this. Vertical asymptote gives you the behavior of the function as x get closer and closer to a particular x value. And horizontal asymptote gives you the behavior of the function as x goes either to negative infinity or positive infinity. Well, what are slant asymptote? Obviously it means it is not vertical, it's not horizontal, it's some kind of inclined. Well, you notice, look at this function. F of x equal to 4x squared minus 8x plus 10 over x minus 5. Does it fit into any of the categories we discussed so far? No. Why? Because here the degree of the numerator is greater than the degree of the denominator. Now that makes it all the more different. Now in this case there are no horizontal asymptote, but you have a slant asymptote. And in order to find the slant asymptote, what we need to do is use long division method to work this out. In other words, divide the numerator by the denominator using the long division method. Now, I'm sure you recall that method. Let's do that on the right side of the board. This will be 4x squared minus 8x plus 10. You remember how to do that. Now, divided by x minus 5. Is that right? And how do you do the long division? This is the first term of the dividend. Now, this is the first term of the dividend, 4x squared. And divide that by the first term of the divisor. So 4x squared divided by x is 4x. Now, I'm going to put these lines the other way around to make it easy for us. Like this. Now 4x squared divided by x is 4x, and we write it on top there. Now once you write there, multiply 4x by x. 4x times x is 4x squared. 4x times negative 5 is negative 20x. Well, once you've done that, subtract the terms below from the terms above. And always the first two terms will go. 4x squared minus 4x squared is 0. And watch this. We are subtracting the terms below from the terms above. That is negative x minus negative 20x. What is that? Negative 8x minus negative 20x. When you subtract a negative, it becomes positive. And that will be positive 12x. Is that right? Negative 8x minus negative 20x is positive 12x. Now bring down the plus 10. What is the next step? Divide 12x by x. That will be plus 12. Write it to the right of 4x. And now multiply 12 by each of these terms. 12 times x is 12x. 12 times negative 5 is negative 16. Alright? Now, subtract the terms below from the terms above. 12x minus 12x is 0. 10 minus negative 10 is 70. Therefore, what will you do? What is the answer? The answer is, we can write it like this: 4x plus 12 plus 70 over x minus 5. That is the remainder. Now, remember, the meaning of a horizontal asymptote is the limiting value of this when x goes to infinity. So let's find the limiting value of this when x goes to infinity. Limit x goes to infinity of 4x squared minus 8x plus 10 over x minus 5 is the same as the limiting value of this. So I'm going to say it's the same as limit x goes to infinity of this quantity. Let me write that down. 4x plus 12 plus 70 over x minus 5. Well, if you look on the right side, limit x goes to infinity of 70 over x minus 5. What is this? What is this? If you take the limit of that last value, it will be 0 because x on the denominator. And so, limit x goes to infinity of this quantity will be 4x plus 12. What that tells you is that if you draw the graph of this function, as x gets very, very large, the function value will approach this line. 4x plus 2 is a straight line. Now, let me see if I can draw that straight line for you. 4x plus 12, if I draw that graph. Can you draw the graph of 4x plus 12 just like that? 4 is the slope, 12 is the y-intercept. So if I say this is 4, this is 8, this is 12, this is the y-intercept. And the slope is 4, and so the graph is going to be something like this. This is the graph of y equal to 4x plus 12. Now, what this suggests is, as x gets very close, let's use the broken line there. As x gets closer and closer to negative infinity, or positive infinity, the value of the function will get closer and closer to this line. And therefore, this line, which is called y equal to 4x plus 2, is called a slant asymptote. Well, let's see if we can draw the graph of this. All right, let's sketch the graph of this function using this information that its slant asymptote is 4x plus 12. That is, as x goes to negative infinity or positive infinity, the function value will approach this line. That's the meaning of that. Well, to sketch the graph, we can also obtain some fundamental information about this. That is, we know that it has a vertical asymptote. Does it got a vertical asymptote? Yes. So the vertical asymptote is obtained by setting the denominator to 0. The denominator is x minus 5. So x minus 5 equals 0 gives you x equal to 5 is the vertical asymptote. That means as x gets closer and closer to 5 from the left or from the right, the function value either goes to negative infinity or positive infinity. A couple of other information you can get are the x and y intercept. Now, do you know how to find the x and y intercept? I think it will be almost an insult to ask you that, is that right? Because it's something that you learn in elementary algebra. Now, x-intercept is the point where the function graph cuts the x-axis. And along the x-axis, the function value is 0. So, set the function equal to 0, f of x equal to 0. Well, when you set the function equal to 0, tell me, when does a rational expression become 0? A rational expression becomes 0 when its numerator is 0. So f of x becomes 0 when its numerator equal to 0. 4x squared minus 8x plus 10 equal to 0. Can you solve this equation? Now, I will show you in a while how to solve equations like this on the calculator, on a TI-84 or a TI-83 plus. Alright? Or you can use the quadratic formula to solve this. If you solve this, it looks like it does not give you any real solutions. Now, if an equation like this does not give you any real solutions, what that means is the numerator cannot be 0. If the numerator cannot be 0, it means the graph of the function will not cut the x-axis. So the conclusion is no x-intercept. No x-intercept. The graph will not cut the x-axis. Now, how about the y-intercept? How do you find the y-intercept? Y-intercept is obtained by finding the value of f of 0. So y-intercept is actually f of 0. Put x equal to 0. When x equal to 0, all these will become 0. You get 10 divided by negative 5. So f of 0 is negative 2. In other words, the y-intercept will be here. If this is 4, that's negative 4. This is negative 2. The y-intercept is here. The graph will cut the y-axis there. Okay, we now know many things. We know this is the vertical asymptote. This is the slant asymptote. The graph will not cut the x-axis. The graph will cut the y-axis here. Can you therefore sketch the graph of this function? Alright? What will be the behavior of the function for very large negative x values? The function value will be very close to the slant asymptote. So look at the way it's going to come. It will be close to the slant asymptote, right? So let me use this. It will be close to the slant asymptote, and it will come, it cannot cross the x-axis, but it will cross the y-axis here. So let's go there. It will cross the y-axis, and what will it do? As x gets closer and closer to x equal to 5, it will go to negative infinity. Look at that. It's very easy for us to visualize that. Now, what will be then on the other side? If the graph goes to negative infinity on the left of x equal to 5, it must come from positive infinity on the other side. So here it comes, and as x increases for large values of x, where does the graph go? Close to the slant asymptote. It will go that way. And look at the graph. It gets a beautiful graph of the function. Now, without using any other information, just using the information on the vertical asymptote, slant asymptote, the x and y intercept. And we will be doing more of this in our next class. Now I want you to stop the video and find the vertical and horizontal asymptote of these two functions and sketch the graphs of this, and then try it on the calculator and see how you did. Alright, so find the vertical and horizontal asymptote. You can also find the x and y intercepts if you want, and use those information to sketch the graphs of these two functions. Okay. Let's now try this one. Find the horizontal asymptote of f of x equal to negative 3x plus 1 all over square root x squared plus 1. Now again, what is a horizontal asymptote? Well, horizontal asymptote is the behavior of the function when x goes either to negative infinity or positive infinity. And we said if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote will be the ratio of the leading coefficient. Now here, are the degrees the same? Well, that is, it looks like they are the same, isn't it? Because square root of x squared is x. But in a case like this, when x goes to negative infinity and x goes to positive infinity, the behavior may be different. So in order to find the behavior when x goes to negative infinity, what we need to do is, let's try this. Limit x goes to negative infinity of this. What we're going to do is divide each term by negative x, because x is negative as x goes to negative infinity. Let's divide each term by negative x. Alright, it will be negative 3x divided by negative x plus 1 over negative x all over square root of, now remember, when you divide a square root term by, say, negative x. Now look at this. If you want to divide, say, x squared by negative x. Well, you can actually put it inside the square root. You see, if negative x can be written as square root of x squared, isn't it? Because negative x when squared becomes positive x squared. So, square root of x squared divided by negative x is the same as square root of x squared divided by square root of x squared. Or we can write this as square root of x squared divided by x squared. In other words, dividing each of these terms by negative x, when that negative x is taken inside the square root, it becomes x squared. So it will be x squared over x squared plus x over x squared. I hope you understood what I actually meant. You want to divide square root of x squared by negative x. By negative x. It is the same as square root of x squared divided by negative x. Well, try it again. Square root of x squared divided by negative x is square root of, that means we're going to put both inside the square root. It will be square root of x squared. When this goes under the square root, it becomes x squared. So that will be square root of x squared divided by x squared. And therefore, when you divide this by, each of this by negative x, it becomes x squared over x squared plus x over x squared. And what is that equal to? That will be limit x approaches negative infinity of 3 minus 1 over x over square root of 1 plus 1 over x. That will be limit x approaches negative infinity of this quantity. But when x goes to infinity, 1 over x will be 0 and this 1 over x will be 0. So what will be left is actually a 3. What it tells you is that as x gets closer and closer to negative infinity, or as x gets very large negative values, the function value will approach y equal to positive 3. Now, this is when x goes to negative infinity. And because we were finding the limit when x goes to negative infinity, we divided each term by negative x. Now, on the other hand, if I want to find the limit when x goes to positive infinity, what will I do? I divide each term by positive x. All right, let's try that now. Let's take this out and find the value, find the limiting value of this function when x goes to positive infinity. That is, limit x goes to positive infinity of this, divide each term by positive x. It will be negative 3x divided by x plus 1 over x all over, and now we are dividing the denominator by x. Again, as I said before, square root of x squared divided by x is the same as square root of x squared divided by, if you want to take this inside the square root, it will become a square. It will be square root of x squared divided by x squared. So, what will be then the denominator? The denominator will be square root of x squared divided by x squared plus x over x squared. Now, that will be limit x approaches positive infinity of, the value of that will be negative 3 plus 1 over x over square root of x squared over x squared is 1 plus x over x squared is 1 over x. And as before, the limiting value of 1 over x when x goes to infinity is 0. So both these 1 over x will be reduced to 0 as x goes to infinity. And that gives you the limiting value is negative 3. What it tells you is that in the limit when x goes to negative infinity of this function, f of x, we found it equal to 3. As x goes to negative infinity, the function value will get closer and closer to y equal to 3. But limit x goes to positive infinity, the value of the function is negative 3. What it tells you is, as x goes to positive infinity, the function value will get closer and closer to negative 3. Well, so there are two horizontal asymptotes. The behavior of the function as x goes to positive infinity is different from the behavior when x goes to negative infinity. Can we now use these information to sketch the graph of this function? We now know that as x goes to negative infinity, the function will approach y equal to 3. And as x goes to positive infinity, the function will approach y equal to negative 3. Well, to sketch the graph, let's also get the intercepts. What is the x-intercept? Can you give me the x-intercept here? The x-intercept is actually f of x equal to 0. Set f of x equal to 0. When you set the function equal to 0, it is the numerator that will be equal to 0. In other words, if you put negative 3x plus 1 equal to 0, what is x equal to? X equal to 1/3. So the x-intercept is x equal to 1/3, y equal to 0. Now, let's try and draw the graph there. All right, let's see, that is the x-axis and that is our y-axis. Do we have a vertical asymptote? Vertical asymptote occurs where the denominator is 0. All right? When will this denominator become 0? This denominator becomes 0 when x equal to 0. Therefore, x equal to 0 is a vertical asymptote. So, x equal to 0 is a vertical asymptote. Now look at the information you have. You have y equal to 3 is a horizontal asymptote. Y equal to negative 3 is another horizontal asymptote. But you must understand the distinction there. When x approaches negative infinity, the function approaches y equal to 3. When x goes to positive infinity, y approaches negative 3. The x-intercept is this point, x equal to 1/3, y equal to 0. And x equal to 0, that is the y-axis, is the vertical asymptote. And I can highlight it. This is the vertical asymptote. And x equal to 1/3, if this is x equal to 1, 2, that will be negative 1, negative 2. The graph will cut somewhere here. That is 1/3, 0. Is there a y-intercept? Does the graph cut the y-axis somewhere? Well, y-axis is a vertical asymptote. That means the graph cannot cut it. There are no y-intercepts. Well, and therefore, let's see. Now, y equal to 1, 2, 3. This is a horizontal asymptote. Y equal to 3. Similarly, y equal to negative 3 is a horizontal asymptote. So y equal to 3 is a horizontal asymptote. Y equal to negative 3 is a horizontal asymptote. Now, help me sketch it. What does it mean y equal to 3 is a horizontal asymptote? You must understand what that means. When x goes to negative infinity, for negative values of x, as x approaches negative infinity, the function is very close to y equal to 3. That means the graph will be very close to y equal to 3, but this is a vertical asymptote. Therefore, the graph will go like that. You see? On the left of the vertical asymptote, the function goes to positive infinity. Now that means on the other side, it must come from somewhere. Now, if it is going to cut the x-axis here, and it's going to go along, say, y equal to -3 for positive x values, then the graph must be going like this, you see. Now, actually, in this case, you notice that I told you that's not a rule that you can always apply. If the graph goes to positive infinity on one side, it must appear from negative infinity. No, in this case, it is not. You can see it's appearing back from the positive infinity. So that's not a rule that you can always apply. Well, so this is the graph of the function. As x goes to negative infinity, the function is close to y equal to 3, and as it gets closer and closer to x equal to 0, the function value goes to positive infinity. And on the right side, as x gets closer and closer to 0, again you get positive infinity. And it cuts the x-axis at 1/3, and then as x goes to positive infinity, it gets closer and closer to y equal to -3. And that is the graph of a rather complicated function. Is that right? Okay. Before we finish the lesson, let's have a discussion on x and y intercepts. What is an x-intercept? X-intercept occurs where the function cuts the x-axis. And what is the value of the function on the x-axis? Well, actually, the name of the x-axis is y equal to 0. Along the x-axis, y equal to 0. So, to obtain the x-intercept, we set the function f of x equal to 0 and solve for x. And that's how you get the x-intercept. And y-intercept is where x equal to 0, or y-intercept is f of 0. Alright, let's practice this with a couple of examples. Let's look at a function like this. F of x equal to x to the power of 4 minus 8x cubed plus 18x squared minus 16x plus 5. And to find the x-intercept, we should take this function and set it equal to 0. X to the power of 4 minus 8x cubed plus 18x squared minus 16x plus 5 equal to 0. Is it easy to solve an equation like this? Well, I'm going to show you how you can use your TI-84. Now remember, all TI-83s will not do it. A TI-83 plus, I think, will do that. And a TI-84 will definitely do it. So I'm going to show you a TI-84 how it does solve equations like this. Now, to solve a polynomial equation like the one I just showed you, we use the menu called Applications. Now look for this called Apps. So press Applications and see what it brings out. Now, Applications menu gives you this. It starts with Finance, so on, Area Form, and you need to scroll down, press the down arrow, and go all the way to the 30th item. If you can count, it goes alphabetically. Go and find something called Polysymote. So press the down arrow. I'm going to take you down to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 29. You get polysymode. That's what we want. So once you reach there, it is selected and enter, and you get the screen and enter there, and it gives you the screen. It's asking you polyroot finder. Alright, that's what we want. So we want the polyroot finder number 1, and that is selected. So enter, and we were asked to enter the degree of the polynomial. What was the highest power of the polynomial? The first term was x squared, of x to the power of 4. So the degree of the polynomial is 4. So we enter 4 and type in 4 and enter. Let's enter there. And then it's asking a to the power of 4, a cube, a2, a1, a0. These are the coefficients. What is the coefficient of x to the power of 4? What is the coefficient of x to the power of 3? I think I have a, well, let's see, our a4 is 1, so type in 1 there. Our a3, the coefficient of x cubed, is negative 8. Oops, I need to clear that. That's 1, enter. a3 is negative 8, enter. a2 is 18, is that right? 18 x squared, enter. Our a1, the coefficient of x, is negative 16. And the constant term is 5. Now once you did that, you need to solve. This is to solve, and that is this button, which is graph. So press graph and it will solve the equation for you. Alright, wait until it solves it for you. I think it's going to take a little while because the equation is a little complicated. Is that right? Yes, it solved it. It says x1 equal to 0.999. When you see that, read it as 1. And x2 equal to 5. It gives you 2 solutions for x. X equal to 1 and x equal to 5. And the other solutions, well, you have a 4th degree polynomial. You expect to get 4 solutions. 2 of them are real here, and 2 are not real. So we will use the real solutions only. So take a note of that. X equal to 1 and x equal to 5 are the 2 solutions. What are the x-intercepts that we have? The x-intercepts are x equal to 1, y equal to 0. That's one x-intercept. X equal to 5, y equal to 0 is the other. Okay, what is the y-intercept? Y-intercept is f of 0, and in the function when you put x equal to 0, your y-intercept is 0, 5. Always write the intercept as an ordered pair, x and y. X equal to 0, y equal to 5. So you got the x-intercept and y-intercept. And you should be able to find the x and y intercept of any function like this. Let's now find the x and y intercept of this trigonometric function. I thought that would be useful to you because most of you struggle with solving trig functions. F of x equal to cos x minus 0.5 cos 2x. Well, to find the x-intercept, we set the function equal to 0. So we say cos x minus 0.5 cos of 2x equal to 0. Now, how do you solve this equation? I've been telling you in the last two classes that if you want to solve a trig function, then all the trigonometric ratios involved must be the same type of ratio. If it is cos x, then the other one also must be cos x, not cos of 2x. Because you cannot solve, you see, it's like x plus y equal to 2. Can you solve x plus y equal to 2 and find the value of x? No. X plus 2x equal to 0 you can solve. In the same way, if this is cos x, this also must be cos x. So you need to reduce the trigonometric ratios in the same form. Now tell me, how do you write cos of 2x in the cos x form? Cos of 2x is, in the last class I gave you 3 forms of cos of 2x, and I told you must write them down and learn. Cos of 2x has got the first form, cos squared x minus sine squared x, but that's not the one we want here. And then cos of 2x is 2 cos squared x minus 1. 2 cos squared x. Yes, cos x times cos x. That's the one we want. So cos of 2x is 2 cos squared x minus 1. So we replace that here. So we say cos x minus 0.5 times, instead of cos 2x, we write 2 cos squared x minus 1 equal to 0. And now you distribute that 0.5, it gives you cos x minus 0.5 times 2 is 1, minus cos squared x plus 0.5 equal to 0. Now, what this gives you is actually a quadratic in cos x. Now, you need to rewrite this as a proper quadratic. So what I'm going to do is, I'm going to write it on top so that I can use the entire board. Well, how do you write it in the proper quadratic form? A proper quadratic is ax squared plus bx plus c equal to 0. So the square term must come first. So that will be negative cos squared x, negative cos squared x plus cos x plus 0.5 equal to 0. Or we can multiply each term by negative so that you can make the first term positive, and that will give you cos x cos squared x minus cos x minus 0.5 equal to 0. That is our quadratic. X squared minus x minus 0.5 equal to 0. In the same way, this is cos squared x minus cos x. Now, if you have difficulty dealing with this, you can simply call cos x equal to x or cos x equal to u. You want to do that? Let's say cos x equal to u. And that will give you this equation as u squared minus u minus 0.5 equal to 0. That's a quadratic. And when you solve for u, you must then come back and say our u is cos x. Alright, can you solve this quadratic? U squared minus u minus 0.5 equal to 0. Actually, you can go back to the calculator, just the polynomial, to the degree of the equation is 2. Our coefficient here is 1, and this coefficient is negative 1, and the constant term is negative 0.5. You can do that. But you can use the quadratic formula, is that right? And what's the quadratic formula? U in this case is negative b. Let's pick out a, b, and c first. A x squared, a equal to 1, our b equal to negative 1, is that right? And our c equal to negative 0.5. So we've got u equal to, what's the equation for quadratic? Negative b plus or minus square root b squared minus 4ac all over 2a. So that will be negative b, that will be negative of negative 1 plus or minus square root of b squared is 1 minus 4 times a is 1, c is negative 0.5 all over 2a, 2 times 1. And what does that give you? That gives you 1, negative, negative 1, plus or minus square root of, these two negatives will become positive, is that right? 4 times 1 is 4, 4 times 0.5 is 2. Two negatives become positive, that will be square root 1 plus 2 all over 2. And what's that equal to? That will be 1 plus or minus square root 3 over 2. It gives you two values. 1 plus square root 3 over 2, 1 minus square root 3 over 2. What are those values? Can you use the calculator and give me those values right away? Well, I hope you got these values. We got two values. 1 plus square root 3 over 2 is 1.37. And 1 minus square root 3 over 2 is 0.37. Now remember, both these values are for cos x. So we got to now come and say cos x equal to 1.37, that is one possibility, or cos x equal to negative 0.37. But tell me, is this possible? Can cos of x be equal to 1.37? No. Why not? The maximum value of a cos function is 1. A cos function cannot be greater than 1. And so cos x equal to 1.37 cannot happen. So we don't deal with that. Therefore, we have only one value, cos x equal to negative 0.37. So we got to now find x equal to cos inverse of negative 0.37. Well, how do you find that? Go and use your calculator. X equal to cos inverse of negative 0.37. Remember, make sure that your calculator is on radian mode. This is what you get. Cos inverse of negative 0.37 is 1.95, let's say. And if you don't know where to go for that, it is second cos will give you cos inverse. Okay? Well, if we got x equal to 1.95, well, can we stop here? Well, no. Why not? Because cos can be negative in which quadrant? Well, remember in the last lesson I told you the trigonometric ratio of sine is positive in the first and second quadrant. So if you get sine x equal to say 0.12, this x has got two values, one in the first quadrant, one in the second quadrant. Similarly, cos x equal to negative 0.37. Cos x is positive in the first and fourth quadrant, which means cos x is negative in the second and third quadrant. So you can have a value in the second quadrant. So this 1.95 is the second quadrant value. Now, cos x is negative in the second and the third quadrant. That means there is a third quadrant value you must have. Now, how do you find that value? If you know the second quadrant value, how do you find the third quadrant value? Now, you must know that if this is the second quadrant number, then this is its reference number. From your trigonometry course, you know that. Now, this angle will be pi minus 1.95. And the reference angle in the second quadrant will be the same as the reference angle in the third quadrant. So this will be pi minus 1.95. So then what is this angle? This angle can be obtained, well, now this reference angle, pi minus 1.95, is 1.19. That means this angle is also 1.19, and therefore the angle in the third quadrant is pi plus 1.19. Pi plus 1.19. And what is that number, pi plus 1.19? Is that 4.33? That's right. So your x values are 1.95 and 4.33. Your x-intercept are 1.950 and 4.330. Those are the two x-intercepts. All right. Now, before you get too tired, I want you to try these two. Find the x and y intercept of these two functions. All right? And if you need any help, let me know.